Hello everyone, and then welcome to another video. Okay, so in this video we'll be treating analysis of structures. Okay, so we are trying to analyze structures, how structures look like, how structures get their strength, and then the force that hold these structures together. Okay, the joints that come together to form these structures. That's what this concept under strength of materials is all about. Okay, right, so it's into two portions. Okay, we will look at the method of sections, okay, and then the method of joints. Okay, so the method of sections is when you have a structure but there is a cut, okay, there is a break within that same structure. Okay, so you tend to find the forces whenever there is a break or a section being cut. Right, and then we have joints. Okay, joints is where we mostly concentrate on the portions of the structure, okay, that holds the entire body of the structure together. Okay, that gives a strength. Okay, right, so without further much ado, let's just dive right into this video. Okay, so in case you are new to this channel, I would urge you to subscribe to the channel. In case you enjoy what you'll be studying today, I would highly urge you to subscribe. Okay, like the video, turn on your post notifications so that you don't miss out on any uploaded video. Like the video, share, and then in case you have any other questions, you just let me know in the comment section and I will reply to them as soon as possible. Okay, right, so let's look at trusses or truss or truss. Okay, irrespective of how you pronounce that, that's your own preference. Okay, right, and then we have what frame. Okay, we have truss and frames. Okay, so for truss, all the load, okay, all the loads are applied at the joints. Okay, this is what we mean by the loads are being applied at the joints. Okay, from here you can notice that there's a joint. Okay, there's another joint. Okay, so that's where the forces are. Okay, right, this is another joint, that's another joint, that's where the forces are. But when we look at frames, okay, frames do not have their loads at the joints. Okay, so from here you can notice that there's something like a joint, but there is no load. Okay, there is no force over here. There's something like a joint, somehow a joint, there is no force over here, but you could notice that these forces or loads are just applied at different portions of the structure. Okay, right, so from here, okay, there's something like beside the structure or back of the structure, and then this at the top of the structure. Okay, that's where the loads are being applied. Okay, they are not applied at the joint. So from here we could notice that you've been able to understand the concept of what truss and what frames. Okay, right, so let's proceed. Now we'll be looking at what the conditions for what equilibrium. Okay, we know what equilibriums are. Okay, that's where 2 points are the same. Okay, right, so when we say the conditions for equilibrium for method of structures, means that the summation of what the forces on the x-axis, okay, have to be equal to what 0, and the same applies to what the y-axis. Okay, and then sometimes we take the moment. Okay, we equate the summation of the moment of a certain point, okay, to be equal to 0. Okay, right, so let's say we take the moment about this point, okay, and then we equate that to 0. So that will be our reference point. Okay, right, and then we also take into consideration free body diagrams. Okay, listen to this very, very attentively, very carefully. Once you are given any question under mechanics, okay, or strength of materials, and then you don't draw the free body diagrams, and then maybe you end up in the correct answer, you might be marked down. Okay, free body diagrams are very, very important. They are even important, much more important than what the solution you are trying to come by, okay, or prove. Okay, right, because the free body diagrams enables you to see beyond the structure. Okay, right, and then we have what tensions and what compressions. Okay, so in simple terms, you know what tensions are. Okay, something like a stretch. Okay, and then compression is something like you compress, okay, right? It's self-explanatory. There's no need to run your head around this, okay? Let's just take an example with it, okay, and then we get to understand the concept, okay? So we have what? A certain body, okay? So these questions under sections, okay? So initially I stated that sections, we just determine the forces within cast and what whenever there is a break in a body, okay, or in a section, okay? So yes, so for this question you are trying to what calculate what the using the method of section to calculate the forces within a body which has what a section being cut off, okay? So from the question there is this portion of the body which is being cut off, okay? That's a section, okay? It's being cut off, okay? So we have a certain A and A, okay? So this section is being cut off. That's where we introduce our what free body diagram, okay? That's where free body diagram is, okay? And then we have certain reactions over here, okay? Reactions over here. So this reaction at point A, okay? And then we have what another reaction at what point E, okay? Right. So we have to calculate the forces within what J, I, B, C, okay? So the main point is what calculate the forces within the section which has been cut, okay? Right. So without further much ado, let's dive right into knowing how to calculate for the forces within what the cut section, okay? Right. So from onset we could notice that we could just use what principle of what moment, okay? From here we could use principle of moment to find what this RA, okay? Right, because once we draw the free body diagram for the section which has been cut, we will be required to find RA, okay? So why don't we find RA with these possible dimensions and all that, okay? Right, so moments is what about what the force times the distance, okay? Hence we are trying to find what this force or this reaction RA using these distances, and then these already given what reactions, okay? So let's look at the solution, okay? So let's do that, okay? So we are taking moment about point E, okay, so that we could find RA, okay? So in case we were to find what RA, we would have taken moment at point A, but this question is based on what the left hand side of the what the structure. So it's very, very crucial we take the moment at point E so that we get what the reaction at what point A, okay? So taking moment at point A, we equate that to 0, so that means that we multiply what the reaction by what the distance, okay? That's what moment is. Moment is what moment is equal to what the force times the distance, okay? Right, so let's proceed from there. So from here we have what taking moment from here, so we have what these distances, okay? So when you sum these distances up, 2.5, 2.5, that's 5, 2.5, 7.5, 2.5, that's what 10, okay? So we have what RA, okay? This RA multiplying what a distance of what 10 meters, okay? 10 meters, and then you equate that to what your other what reactions, okay? Right, so from this reaction we could notice that we have what 10 kilonewtons, okay, but with a distance of what, so from the 10 kilonewtons point to this point is what 2.5, okay? So we have what 10 multiplying what 2.5, okay? And then we have what you add that to what 15 kilonewtons, okay? So from 15 kilonewtons to what the moment the point where we are taking the moment, okay, is what 2.5 plus 2.5, that's what 5, okay? So from here we had what from RA to E, and then from here you're having what 2.5 plus 2.5, that's from 15 kilonewtons, okay, to what, so from H to what E, okay? or from C to E, okay? So H to F, and then what? From C to E, that's 5, okay? So we have what? 15 multiplying what? 5, okay? Right, so when you do the calculation, okay, we will end up with what? This will give us what? 10 by 2.5, okay? This is 100, okay? And then you divide that by what? 10, okay? Right, so you end up with RA, okay, being equal to what? 10 kilonewtons, okay? You could notice how simple that is, okay? Now, so from here you might be wondering why I just took the moment at RA and then equated that towards this point. This means that the direction of RA is what? Positive, okay? So that's why I just equated that and then took the moment of what? 15 and what? 10, because once I want to sum everything to 0, I will end up with what? The same thing, but these operation signs might change. This will be negative, and then we have a negative 10 times 2.5 because 15 kilonewton is pointing downwards. Downwards, that's opposite from what? X direction. So that will be negative, and 10 will be also negative, okay? Right, so let's proceed. So let's draw the free body diagram for the section which has been cut off, okay? So free body diagram for the section which has been cut off. So I'm redrawing this section, okay? Right, so let's see, we have what? Right, we have that. So we have a okay, and then we have a point B, and we have what? J, okay? Very important. And we have what? 2 meters, okay? We have our 2 meters, okay? And then we have what? 2.5 meters over here, okay? 2.5 meters, that's over here. So A to B, and then what? AJ, okay? Right, so now let's draw the section which has been cut, okay? So these cut off sections will be what? Now converted to what? Forces, okay? They will be converted to what? Forces. So there is what? One force, there is another force, and this will be another force, okay? So let me use the red one. So this is another force, and then this another force, okay? So that's what we've been able to what? Represent over here, okay? Right, so this is what? BC, okay? So this is BC. So most definitely this force will be what? FBC, okay? And this is what? JI, okay? So this force will be what? FJI, okay? And this is what? BI, okay? So this force will be what? FBI, okay? Or FIB, okay? Doesn't matter, okay? Right, so now all we have to do is just find our forces, okay? FJI, FBI, and what? FBC, and then we already know that we have a certain RA over here, which is what? 10 kilonewtons, okay? So we have to find 1, 2, and 3, okay? But most definitely, or most importantly, in the question we were told to find what? FBI, okay? Or IB, okay? Right, so the notation might change depending on what, however you want to call it, okay? Right, so let's proceed from there, okay? Let's proceed from there. Now, from here you could just also apply what our principle of equilibrium, okay? So we have what? Our moment being equal to 0, x direction, forces in the x direction being equal to 0, and then what? Forces in the y direction being equal to 0. So from here you could take what? The moment at point B, okay? The moment at point B. Right, so let's take the moment at point B. So when we take the moment at point B and then we equate that to 0, this is the point we are referring to, okay? Point B, okay? We are taking moment from point B. So we have what? RA to what? Point B, okay? So we have what? RA multiplying what? Distance, that's what? 2.5, okay? And then we have what? FJI, okay? Because at point B, FBI and what FBC will be equal to 0 because that's the point we are taking our moment, okay? So even though we take the force or the reaction, we won't get any distance, so the distance will be 0. So most definitely when you multiply 0 by the force, it will end up being 0, okay? Right. So we have plus FGI. So for FGI, from point FGI, okay, to where we are taking the moment, okay, perpendicular to the moment is this point, okay? So from here to this point is 2 meters, okay? So we have FGI, okay, multiplying 2 meters, okay? So after that, you just equate that to 0 because FBI has already explained FBI and FBC will be 0, okay? Again, we know that RA is 10 kilonewtons, okay? Right, so we have 10 multiplying 2.5, okay, plus FGI multiplying 2 will be equal to 0, and then once you make FGI the subject, okay, you end up at minus 10 multiplying 2.5, okay, and then you divide that by 2, okay, so we end up with FGI to be equal to minus 12.5 kilonewtons, okay. So now we have FGI to minus 12 kilonewtons. The reason why this negative 12 kilonewtons is because of the direction, okay. So it means that this direction has to be opposite, okay. Now let's proceed. Now let's take maybe the condition for equilibrium, okay. So let's take for the horizontal and the vertical, okay. Let's take the equilibrium for horizontal and vertical. So horizontal means x-axis, vertical means equilibrium from the y-axis, okay. So let's equate that to 0, okay. So it means that we are taking everything in the direction of the y-axis, okay. Now we could notice that FBC, okay, is already in the y direction, okay. We are taking the y direction, so we have FBC, okay, plus FGI, okay. FGI is also in the y direction, okay, and then we equate that to 0. That's the reason why, okay. So let me write this out so that you get to understand, okay. This will make the work a bit simpler, okay. So it means that we are taking all horizontal forces, okay. Every force which is horizontal, so FBC is a horizontal force, FGI is a horizontal force, but FBI and RA are all vertical forces, okay. Right, so from here you know that FBC is unknown, but FGI is already known. That's minus 12.5, okay. So all you have to do is just substitute. So you have FBC minus 12.5 equal to 0. So you have FBC to be equal to 12.5 kilonewtons. You see how simple this is, okay. Now let's take vertical forces, okay. So we have Fx to be equal to 0, okay. So this we are taking only vertical forces, okay. We are taking vertical forces, okay. Right, so let's see our vertical forces. So we have RA and FGI, okay. Right, so we have RA, okay, and then we have FBI, okay, FBI. They are both acting in the positive direction, okay. FBI, and then we equate that to 0. That's why initially I stated that this is you have to know this, okay. It's very important, okay. This is y in the positive direction, x in the positive direction, okay, y in the negative direction, and then we have x in the negative direction. Keep that in mind, okay? Right, so you know RA, okay? So RA, you know that is what? 10 kilonewtons, and then plus what? FBI, okay? FBI to be equal to what? 0. So now, so you know that FBI is equal to what? In simplicity, okay? FBI will be equal to minus what? 10 kilonewtons, because we will just take this one across, okay? Across to this point, making it negative, okay? So now we've been able to find what? Our FBI, okay? This FBI, let me rewrite that. It looks a bit different, okay? Okay, right, so this is FBI. We know what FBC, and then we know what FGI, okay? So when you can redraw this, okay? But you can just insert them, okay? You can just insert them in there, okay? We just you have what? There's minus 10 kilonewtons, okay? And then you have FBC of what? Right, 12.5, okay? 12.5 kilonewtons, okay? This quite straightforward, okay? So now this is another trick you need to know, okay? This is another trick you need to know. You are not usually told, or you are not usually introduced to it, okay? But this is what you can also use, okay? Right, so you can notice that this is what? This acting upwards, okay? This force is acting upwards, and then this force is also acting upwards. So since they are what? Parallel to each other, okay, it means that they have what? They might have the same magnitude, okay? But since they are acting in different directions, okay, the signs will be different, okay? So this is what? RA, which is what? 10 kilonewtons, but this is what? FBI acting parallel to what? RA, okay? But it's what? Minus 10 kilonewtons, okay? And then we have what? FJI being what? Minus 12 kilonewtons, and then we have FBC also acting the same direction, but it's what? 12.5, okay? It doesn't always go by that principle, but most of the times when you talk about what? The directions, okay, they normally coincide, okay? Right. So this you notice that there's quite a simple example, okay, quite straightforward, okay, and then you get to just understand the concept right from the explanation, okay? So I hope this video was very useful, okay? So in case you enjoyed this video, or this video helped you understand the concept of what method of sections, I would urge you to subscribe to the channel so that you don't miss out on any uploaded video which is similar, okay, to these kind of what concepts, okay? Like the video. In case you have any other questions, you can just leave them in the comment section. I'll reply to them as soon as possible, okay? Don't forget to also share, okay? Don't forget to share to your colleagues, okay? Have a lovely day. Bye bye.